Hi, I'm Doug Tyson, here in beautiful York, Pennsylvania, with another AP Daily video. This one is about setting up a test for a difference in proportions. So what are we going to learn in this video today? Well, first, we're going to figure out how to state the null hypothesis for a test for a difference in proportions. And then also, we'll learn how to state the alternative hypothesis for a test for a difference in proportions. A quick reminder about the structure of Unit 6. Unit 6 is about categorical data that can be summarized by calculating proportions of successes. And there are two types of inference that we work on: confidence intervals and significance tests in this unit. In topics 6.2 to 6.7, they covered confidence intervals and significance tests for a single proportion. 6.8 and 6.9 were about confidence intervals for a difference in proportions. And now 6.10 and 6.11, they're about significance tests for a difference in proportions. A few other reminders from Unit 6. Confidence intervals are used to estimate the value of a population parameter, and basically they're an interval of plausible values for a parameter based on the sample data. Meanwhile, significance tests, they're used to test a claim about the value of a population parameter, and they assess whether the evidence supporting the claim is likely or unlikely to happen by chance alone. So let's look at an example. Effective eye drops. Bacterial conjunctivitis, commonly called pink eye, causes irritation in those unlucky enough to contract it. Can eye drops containing azithromycin make the recovery faster? In one clinical trial, eye drops containing azithromycin were compared to a placebo eye drop among 279 patients suffering from pink eye. The results? Of the 130 patients who were randomly assigned to the azithromycin drops, 82 were cured within a week. Of the 149 patients who were assigned to the placebo drops, 74 were cured within a week. Do these results give convincing evidence that azithromycin is more effective at curing pink eye than a placebo for subjects like the ones in the study? So the null hypothesis in a statistical test is often a claim of no difference or no change or no difference in effect. And so in our effective eye drops example, the null hypothesis is that there's no difference in the proportion of patients who will be cured in a week, like the ones in the study, using either of the eye drops. And so in symbols, H sub 0, that's our symbol for a null hypothesis. We would say that proportion 1 equals proportion 2, or the difference in the two proportions equals 0. It's a different way to write that null hypothesis. But we want to make sure we know what P sub 1 and P sub 2 stand for. So P sub 1 is the true proportion of patients like the ones in the study who will be cured by the azithromycin drops. And P sub 2 is the true proportion of patients like the ones in the study who will be cured by the placebo drops. The alternative hypothesis, on the other hand, is the claim that we hope to support with the evidence we've collected. In the effective eye drops example, the alternative hypothesis is the proportion of patients like the ones in the study who would be cured by the azithromycin drops is greater than the proportion of for the placebo drops. And that's because the researchers had a belief that the azithromycin drops would be more effective. And so in symbols, here's our null hypothesis. The alternative hypothesis, we use the symbol H sub A. And in this case, we're claiming that proportion 1 is greater than proportion 2, or that the difference, proportion 1 minus proportion 2, will be positive. And again, P sub 1 stands for the true proportion of pink eye patients like the ones in the study who will be cured by azithromycin drops. And P sub 2 is similar, but for patients who will be cured by the placebo drops. So let's summarize what we've seen about hypotheses. about a difference in proportions now. The statement is, the null statement is usually about equality. So typically the difference in the two proportions is 0, or that p sub 1 equals p sub 2. The alternative always has a strict inequality, and so usually that's either that the difference is greater than, less than, or just not equal to, different than 0. When we have a less than or greater than inequality, we say that the alternative is a one-sided alternative. And when we have a not equal to for the alternative, we call that a two-sided alternative. And the choice of the alternative is determined by the research question, the question of interest, and that's determined before any data collection begins. The makers of the drops believe they'd be more effective than placebo drops. And also, we never refer to statistics in our hypotheses, like p sub 1 or p hat sub 2. So we don't want to talk about what happened in the data. We want to talk about what we believe is true for all patients, like the ones in the study. And finally, remember to define any parameters you use when you're writing your hypotheses. So specifically and explicitly write out what p sub 1 stands for. So let's practice with one more example. A bright idea. A marketing agent wonders if there's a difference in the percentage of residents in 2 cities who have purchased sunglasses in the last 12 months. Of 400 randomly selected residents of Soultown, 314 purchased sunglasses in the last 12 months. And meanwhile, a random sample of Brightville residents revealed that 452 of 550 residents purchased sunglasses in the last 12 months. Do these data give convincing evidence of a difference in the proportions of residents who have purchased sunglasses in the past 12 months in these 2 cities? And if you're asked whether or not the data give convincing evidence about a claim, that's a test of significance. It's a signal that you're looking at a test of significance or significance test. We're going to state appropriate hypotheses for the agent's test. So here's our question. Our null hypothesis is that there's no difference in the 2 proportions. So p sub s is equal to p sub b, or that the difference in the 2 proportions is 0. The alternative is that p sub s is not equal to p sub b, or that their difference is not equal to 0. Why not equal to? Well, remember, we were wondering whether there was evidence of a difference. We weren't sure if one city was going to have a higher proportion than the other. So when we're asked about just a difference, that means not equal to. And remember to define our parameters here. P sub s is the proportion of all Soultown residents who purchased sunglasses in the past 12 months. And P sub b is the proportion of all Brightville residents who purchased sunglasses in the last 12 months. So what should we have taken away from this video? Number 1, how do you state a null hypothesis in a test for difference in proportions? P sub 1 equal P sub 2 is a null hypothesis. And we should remember to define our parameters. How about the alternative hypothesis? Well, it's either that P sub 1 is greater than or less than or just not equal to P sub 2. And remember, you can also state these as differences in proportions, that the difference is equal to 0 for the null hypothesis, and that the difference is either greater than, less than, or just not equal to 0 for the alternative. I'm Doug Tyson. Thanks for watching another AP Daily video. I'll see you in the next video. Peace.